All right, welcome back to the Honors Algebra 2 conclusion of Chapter 11. So I know we've done videos for sections 11.3 and 11.5, and obviously we had class for the other sections in Chapter 11. With that being said, this is kind of our wrap up of Chapter 11, so let's go through what we've done. Let's start with mean, median, and mode. Mean is the average, median is the number in the middle, mode is the number that occurs most often, and range is the difference between the highest and lowest value. So I'm going to put them in order here. So 10, 11, 11. There's 3 12s, a 14, a 15, a 16, and a 17. So again, I just took all the numbers here and put them in order from smallest to largest. And so let's talk about median. We're going to talk about the number in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 numbers. So you're talking about 1, 2, 3, 4, the fifth number one direction, the fifth number, and so right in between. So again, between those two would just be 12. Mode is the number that occurs most often, and range is the difference between the highest and lowest value. Notice that I skipped over mean. Mean, you're going to have to take a few minutes, add them all up, divide by how many values there are. So if you want to hit pause right now. And now we're back. So I added them all up, divided by the numbers there are, and so there are 13. Standard deviation, you are going to have to be able to do standard deviation by using the chart. That does not mean that you can't go ahead and do standard deviation using your calculator, but you must show the correct work or an understanding of how to get standard deviation. So again, hitting pause for a second, I want to find the average of the 5 numbers there. All right, so when I put those in, I ended up getting 38.6. And so now the next one is taking the number minus the average. So taking 33 minus 38.6 and doing that for each of these. And then taking that number and squaring it. Now when you square it, you will always get a positive value. So don't forget, we put things in parentheses if you are squaring a negative number and using a graphing calculator. And now I want the average of the last row. So if I take the average of the last row, so add them all up and divide by how many there are, take the square root of that, and my answer to the standard deviation is 4.27. So again, add them all up, divide by how many numbers there are, and then take the square root. This one, they're expecting you just to use your graphing calculator. They're not expecting you to actually do the chart. So if I'm adding all these up and dividing by how many there are, notice that it's every month of the year. So again, this would be the population standard deviation. So the average would be 49.04 and the standard deviation would 18.396. I went ahead and rounded to 3 decimal places. Next one, now we're actually dealing with standard deviation, and you will be given a chart. So you will be given the chart that deals with all these, and so I'm going to put in some numbers here. So this is 34%, 13.5%, 2.35%, and 0.15, and the other side would be the same. So now it says 3,000 local high school students who took the ACT. The average ACT is normal distributed, and the mean score was a 19.3, and the standard deviation was 2.6. So now 19.3 was the average. So adding 2.6 each time. So 21.9, adding another 2.6 would be 24.5. So now they want to know what percent falls between those two numbers. You're talking about adding 34%, 13.5%. And so finding the number of percent between those two, it'd be 47.5%. And again, you will be given a chart that will have the percentages on there. How many of the 3,000 students should we expect to have an ACT score between that? So again, if there's 3,000 students of which we are expecting 47.5% of those students. So I multiply 3,000 times 0.475, and I should expect roughly 1,425 students to actually get an ACT score between that range. Scores on the first semester final exam are normally distributed with an average score of 83 and a standard deviation of 6. If I received an 87 on the test, what percentile am I compared to the rest of the class? So now we're going to get a z-score. Again, the formula for z-score will be given to you. You take the score that you're looking for, 87, so x minus the average divided by the standard deviation. So that formula will be given to you. So 87 minus 83 divided by 6, we get a 0.666 or a 0.7 on your z-score. Again, go to the z-score chart. This is located on the back of your review guide. And so the z-score chart would give you for 0.7 would be 0.7580. So that would be a 75.8%. And again, I didn't write that out very well there. So a z-score of 0.78 on the chart would be 0.7580, which then means that 75.8% of the population is below. It represents symmetric, skewed, or skewed right, or skewed left, or normal. I would accept either that with symmetric. So again, going up, going down, I would consider this to be symmetric, or again, a normal curve. Looking at the next one, this is definitely, all the information is to the left, which actually means that it is skewed to the right. These are kind of some of the things that you're going to need to know the definition of. So you may want to go back through your notes: population versus a sample, a parameter versus a statistic, different types of samples. Now on the test, they are not going to make you memorize each one of these, but they'll give you the words and expect you to know what that means. And the same with different type of data collection. They're going to give you this and they're going to ask you to know the difference between those. So here's some questions to go along with that. In Roscoe, a survey of 600 homeowners found that 200 of them want a new code involving fences over 6 feet tall. What would be the population? So again, give me an example of what population would be for this particular scenario. So if you want the population, you would need to talk to all the Roscoe homeowners. So now, what is the actual sample that they did in this particular situation? They talked to 200, or excuse me, they actually only talked to 600, sorry, of the homeowners. Please be careful here. They're asking you parameter versus a statistic and explain. I'll be honest with you, there's a lot of people that will not, they'll just put parameter, they'll just put statistics. So 93% of all the Honors Algebra 2 students take honors trig pre-calc. A parameter is when you talk to everybody. So since in this situation they talk to all the Honors Algebra 2 students, this would be a parameter, and the reason is the word all. Okay. A survey of 235 customers in a male prefer to do their shopping on Black Friday. This would be a statistic. And again, reason, not all the shoppers. Identify which type of data collection. This is going to be a little bit more challenging for some people. And I see that we went from 10 to 12. So just bear with me. I will pause at the end and we will go back and do number 11. So again, I apologize for that. It looks like we skipped number 11. And so at the end, I will make sure to cover that. Identify the method of data collection each situation describes. Is it an experiment? Is it an observational study? Is it a survey, or is it a simulation? So a researcher records the number of people that used a coupon at a local restaurant. So again, is not doing anything to anybody. They're actually, this is considered an observational. You're just observing how many people walk in and use a coupon. Teacher gives a test A to half the students and test B to the other half of the students. This would be considered an experiment. You're trying to see which test is going to be the better test for those students. Rewrite the survey. We didn't do this much on the actual notes, and so I really want to make sure to take a few minutes to talk about this. Do you think the city should replace the outdated police cars it is using? Why is this survey biased? Because ultimately the person is telling you their opinion in the question. It's not the do you think the city should replace, it's the outdated police cars. They're basically telling you that the police cars are outdated and therefore they should be replaced. Anytime you're asking a survey question, you want to try to stay unbiased in your question. So rewriting this is, do you think the city should replace the police cars? Again, now you're not giving your opinion in the matter. Okay, you're just asking, do you think the city should replace the police cars? Again, using words that give your opinion in the question ultimately make the question biased. In a survey of 735 students, 81% said they prefer final exams before winter break. What is the margin of error? Again, this formula will be given to you. So plus or minus 1 over the square root of 735, which means that roughly plus or minus 3.7%. So there's your margin of error. So even though your actual data would be one thing, hey, 81%, we can expect a margin of error of 3.7%. Now they're not asking this, but that means you could subtract 3.7%, so that would be the smallest value you should actually expect, and add 3.7%, and that would be the largest. So that's what we're going to do in the next question. We're going to find the margin of error. So the margin of error of this particular survey, in which you surveyed 1,680 adults, we're asked which one is their most likely news source. And so that would be a margin of error of 2.4%. So now they're asking what people believe that the newspaper is the most likely news source. So now if 9% is what we got as our actual data. If I subtract 2.4%, that would be 6.6%. And as high as then 11.4% if I added 2.4%. All right, I'm going to pause for 1 second and I'm going to add in question 11, so bear with me. All right, so I'm back here. Question 11 now. You want to determine whether the people in your neighborhood like a new park that is being built. Identify the different type of sample. Self-selected, systematic, stratified, or cluster. You select all the people on one block. So now you are basically, you have everybody's divided up into blocks, and you talk about all the people from one block. That would be considered a cluster because, again, they've been divided up into blocks, and then you talk to all the people in one particular block. The next one, you ask every fourth house in a neighborhood. That would be considered systematic because you have to have a rule then. A rule says that you're going to talk to every fourth person. All right, so now that concludes the Chapter 11 review. Hopefully this will be able to help you out. Our plan is to probably give the test when we get back or to come up with some different type of assessment to see whether or not you understood the material in Chapter 11. Be safe, be healthy. This is ultimately the end of, so spring break then starts after this, and so enjoy your break.